High in the Karakoram, beyond the crowded routes of K2 and the familiar paths of the Baltoro, stands a mountain almost never spoken of in public reports. Shadow Peak is rarely climbed, rarely photographed, and rarely named outside the circles of researchers and local porters. Yet for more than half a century, it has carried a quiet pattern, subtle shifts in ice, strange lights beneath the surface, pressure drops that last only seconds, and the unexplained disappearance of climbers who followed routes that should have been safe. Nothing here moves quickly, nothing announces itself. Instead, the mountain offers small signs, a vibration, a pulse, an echo, a glow. Tonight, we walk through the full record, every anomaly, every measurement, and every quiet moment that points towards something operating beneath the ice. Settle in, slow your breathing, and let the mountain speak in its own pace. The passage under the blue ice. Shadow Peak rises west of K2, separated by a narrow saddle of snow and fractured stone. It does not stand as tall, yet its reputation has grown through quiet warnings passed from climber to climber. The first official record came from a 1,953 Pakistani survey led by Captain Rahim Ullah. His notes mentioned ice that sounds hollow and light that bends in strange ways. For years, these descriptions were treated as exaggerations, but later teams reported similar effects along the ridge. On the 11th of June 1987, 3 climbers arrived at base camp with plans to examine that same ridge. Their leader, Alan Pierce, was a geologist from Flagstaff. With him were 2 brothers from Rawalpindi, Imran and Khalid Noor. The group aimed to collect samples from a reflective ice layer that had caught the attention of satellite analysts at the time. Pierce believed the ascent would take 3 days. Weather charts for that week showed steady conditions, and climbers on the Abruzzi Spur reported calm skies. The team left base camp at 4:20 on June 12. A cook named Farid watched them move across the glacier and later said the surrounding slopes held the sound still, as if their footsteps were swallowed by the cold air. By midday, they reached Camp Thirst. A short message came from Pierce's radio. Reached seam, colour deeper than expected. That was the last contact. A storm formed after sunset. Pressure readings from the Karakoram weather station documented a sudden drop at 19 to 44. Winds rose to an estimated 70 kilometers per hour. Climbers on neighbouring routes saw faint flashes near Shadow Peak. Some believed they were small avalanches. Others noted the flashes appeared in regular intervals, reflecting off a straight surface. A French climber, Mathieu Delon, wrote, "It flickers like a pulse, not snow." When morning arrived, sky remained clear. Base camp waited for a routine transmission that never came. By evening, Farid informed a Japanese team nearby, and a search party was organised. The climb to Camp High revealed no signs of distress. Trail markers stayed upright. Anchor points in the blue ice wall remained untouched. The tent was zipped closed. Inside, the sleeping bags were arranged, and Pierce's notebook rested near the entrance. The final line read, "Seam extends under ridge. Light seen again at 18:2. Okay. Behind the tent, searchers found a long groove cut across the ice. Its edges were polished. Pakistani ranger Abdul Qasim described it as too smooth for a natural slide. The groove led toward a crevasse known as Hollow Gate. Survey notes from the 1,930 seconds warned travellers to keep away from it, with Rahim Ullah writing that sound falls inward and does not return. Imran's ice axe lay near the edge. The strap was unbroken. Snow around it showed no sign of impact. Khalid's gloves were discovered further upslope, placed neatly side by side. Temperatures that morning were negative 18 degrees Celsius, making the removal of gloves unusual. A deeper search began on June 16. Rescuers lowered a camera into Hollow Gate. At 43 meters, the lens captured a patch of glowing ice. When the camera moved close, the glow dimmed. The steel line holding the device swayed without wind. One rescuer, Tetsuo Minami, wrote, "The air moves where the cold should be still." Porters at base camp shared older accounts. A man named Barkat repeated a story from his grandfather, who claimed to have seen white shapes walking in pairs along the saddle in 1924. These accounts were not part of climbing literature, yet they reappeared almost word for word among local workers. Many said Shadow Peak keeps what enters. Satellite images taken on June 17 revealed a new depression along the slope. It ran parallel to the groove found near Camp the First. Snow specialists described the pattern as a lode path without known source. No avalanche activity matched its shape. Search operations continued through June 23. No bodies, ropes, or equipment were recovered. Ice cores taken from the wall showed a thin sediment layer containing metallic fragments. Pierce had noted similar fragments during past research, but never identified their origin. In 1994, German climber Erika Vogel attempted to reach the same ice seam. Her log described a deep vibration underfoot and a moment when her altimeter readings dipped. She wrote, "The mountain feels full, not hollow." Her team turned back before reaching Hollow Gate. By 2001, the Pakistani Alpine Office classified the disappearance as undetermined. The tent, notebook, and axe were stored in the regional archive. No technical evidence suggested a fall or slide. Nothing explained the absence of tracks leading past the crevasse. Attempts to study Hollow Gate since then have produced limited results. Equipment often fails around the 30-meter mark. Batteries drain fast. A Canadian engineer named Thomas Grady tested a reinforced probe in 2009. It recorded a steady hum at 37 meters before shutting down. Grady described the hum as a tone that holds its own weight. Guides in Skardu still mention sudden pressure changes and small lights moving along Shadow Peak. These observations never appear in formal hazard reports, yet they persist in conversation each climbing season. The route taken by Pierce and the Knorr brothers remains marked on maps with a dotted line ending at Hollow Gate. The record has not changed since June 1987. The map that should not exist. In the spring of 1991, a folded chart arrived at the Skardu Mountaineering Office inside an unmarked envelope. The paper was thin, brittle at the edges, and printed in the faded inks used by Soviet survey teams during the 1960 seconds. At first glance, it appeared to be a routine terrain map of the Baltoro Glacier region. It showed K2, Broad Peak, and the surrounding ridges in standard topographic symbols. What drew attention was a thin corridor shaded beneath Shadow Peak, marked with a code that read Sector 5, S44. No modern map carried that label. No Pakistani, Italian, or Japanese survey had ever recorded any subsurface passage in that area. The officer on duty, Javed Ali, sent the chart to Islamabad for authentication. Experts confirmed the material matched Soviet military mapping stock from 1963. The ink composition also aligned with documents from the same period. Yet the coded markings did not match any catalogued Soviet system. A retired geodesist, Pavel Korovin, examined the map in August of that year. He stated, "This is either an experimental layer reference or something added after printing." His notes contained a second remark: "Positioning is too exact for guesswork." Korovin highlighted a sequence of dots running under the northwestern ridge of Shadow Peak. The pattern suggested an underground pocket measured at 3 different depths. The shallowest depth was labelled 46 meters. That matched the depth where rescuers in 1987 had seen the glowing ice inside Hollow Gate. When asked whether the Soviets could have surveyed that far beneath a glacier, Korovin replied, "Only if they used seismic instruments with classified refinements." In September 1991, mountaineer and archivist Helena Thurston travelled to Islamabad to review the map herself. Her expertise lay in early Himalayan mapping projects. Thurston compared the contour lines to modern satellite overlays and noticed a subtle shift. The ridge along Shadow Peak appeared slightly lower on the Soviet map. A 2-meter discrepancy ran across an 80-meter span. She wrote, "The ridge has not changed. The map indicates it was measured differently or measured through another method." Her report suggested a seismic profile rather than a visual topographic record. The most curious feature sat near the margin, a small annotation in Cyrillic that read, "Project Daria Phase 2. Researchers searched military archives but found no reference to Project Daria. The name resurfaced only once, in a 1965 logistics log from an abandoned outpost near the Sheikhsgam Valley. The log listed equipment shipments categorized under deep resonance studies, although no explanation was attached to the term. The outpost closed in 1967 after heavy landslides damaged the site. In October 1991, a Polish climbing team led by Marek Wozniak requested permission to approach Shadow Peak using the coordinates from the map. Their aim was to identify any physical sign of the subterranean corridor. They reached the northern basin on October 19. Wozniak wrote in his journal that the air felt pressured, as if the weather was shifting despite clear skies. His team found a narrow depression along the ridge that aligned with the map's shaded corridor. Snow depth there was significantly lower than in surrounding areas. Wozniak added, "It is like something presses upward, then stops." A member of the Polish team, engineer Tomasz Rybak, used a handheld ground-penetrating instrument at the site. The device captured a faint echo between 40 and 50 meters below the surface. The reading repeated 3 times. Rybak described it as a hollow profile, not shaped by meltwater. When he attempted a 4th scan, the display froze and then shut down. Batteries tested normal after descending to base camp. Several analysts tried to trace the origin of the envelope that delivered the map. Postal records showed no sender name. The handwriting on the address label did not match standard Soviet script. A linguistics expert noted that the writing appeared deliberately neutral, lacking distinctive cultural markers. The postal route began in Gilgit, but the original drop point could not be identified. By late 1992, speculation grew around the possibility of an unfinished Soviet survey project conducted in secret. Some believed the shaded corridor indicated a geological fault. Others suggested it represented an area of anomalous resonance detected during seismic testing. None of these theories matched known research missions recorded in the region. No Soviet team was officially documented near Shadow Peak after 1959. A meeting held in Islamabad between Pakistani and Russian officials confirmed only one detail. The map's paper stock belonged to a restricted batch used for military fieldwork. Russian representatives denied knowledge of Project Daria. They did not deny the map's authenticity. Instead, they stated the document is incomplete. Climbers who viewed the chart noted a line of tiny dashes running toward Hollow Gate. The pattern resembled a route, though not one that could be climbed. It crossed sheer walls and unstable slopes. A Japanese alpinist, Hideki Naruse, remarked, "The path is not for people. It is drawn for something moving inside." When asked what he meant, Naruse replied, "It marks where the pressure travels." The map's existence revived interest in the disappearance of Pierce and the Knorr brothers. Some suggested the team might have reached an unseen chamber. Others pointed to the glowing ice, recorded at 43 meters, matching one of the map's depth indicators. Still, no direct link could be proven. The chart offered no explanation for the polished groove found near Camp 1 or for Khalid's gloves, placed neatly on the slope. Today, the map sits in a climate-controlled drawer at the Islamabad Survey Archive. It remains classified as Origin Unknown. A digital scan shows the shaded corridor with the same crisp lines seen in 1991. It runs under the ridge, passes near Hollow Gate, and stops at a point without a symbol. That point lies exactly beneath the last known position of the missing climbers. No update has been added to the file since the day it was stored, the weather that did not belong there. In July of 1976, long before the disappearance of Pierce and the Knorr brothers, a sudden storm swept across the Baltoro glacier. At the time, only 2 expeditions were near Shadow Peak. One was a British research group measuring snowpack density. The other was a small Italian climbing team preparing an acclimatization route. Both groups recorded the storm in their logs, but their descriptions did not match known patterns in the Karakoram. The event lasted 24 minutes. No cloud front approached, no temperature shift preceded it, yet winds reached levels usually associated with high-altitude cyclones. The British group's meteorologist, Dr. Henry Powell, wrote, "Wind rose from stillness to full force in less than a minute, origin unclear." His barometer readings also showed a sharp fluctuation. Pressure fell rapidly, held at the low point for 9 seconds, and then returned to normal. Powell later stated that he had never seen such a clean return curve in natural storm activity. He described it as a drop scripted by an instrument, not weather. At the same time, the Italian climbers, stationed near the northern ridge, heard a deep rumbling. Their team leader, Sergio Leonardi, described it as a single note carried through rock. The sound lasted roughly 10 seconds. Snow along the ridge shifted uphill rather than down. Leonardi's notes mentioned a wave effect travelling under the surface. When he attempted to measure the phenomenon with a simple inclinometer, the readings oscillated between small values without stabilizing. He wrote, "It is as if the mountain breathes sideways." Satellite images from the United States Landsat program recorded a faint distortion near Shadow Peak that same afternoon. Analysts reviewed the data years later and noticed that one image pixel stretched in an unusual direction. It did not align with atmospheric motion. Some suggested it was an artifact caused by surface reflectivity. Others argued the pattern resembled thermal interference, though no heat source was present. Throughout that day, the British team documented temperature readings every 15 minutes. At 14, the air measured -4 degrees Celsius. At 14:15, the reading remained identical. But at 14:17, 2 minutes before the storm struck, the thermometer dropped to -11 degrees Celsius. Dr. Powell recalibrated his instruments 3 times. He found no mechanical fault. After the storm ended, the temperature rose again to its earlier level. The storm's timing caught both teams at a moment of routine adjustment. The British researchers were sorting snow density cylinders. The Italians were testing crampons against an ice wall. When the wind hit, powder rose from the surface and formed a spiral shape, visible from both camps. Lenardi described the spiral as perfectly upright, without twist. His climbers watched it spin for several seconds. When they moved closer, the spiral flattened instantly, as though pressed down by an unseen force. After the storm, both groups checked surrounding slopes for avalanche signs. None were found. No fresh fractures appeared in the snow. The ice walls showed no new cracks. Despite the storm's intensity, it left no visible damage. Powell noted it behaved as if the wind did not touch the mountain. In the following weeks, the event faded from scientific discussion. Powell filed a short report with the Royal Meteorological Society, which stored it in an unindexed folder. Leonardi mentioned the storm only in his private diary, but in later years, climbers began referencing a silent pressure that sometimes moved through Shadow Peak before weather changes. Their accounts described quick drops in pressure, followed by short bursts of wind. A Pakistani porter, Sadiq Khan, told a 1,985 climbing party that the mountain sometimes pushes the air down the wrong way. When researchers revisited the 1,976 logs after the 1987 disappearance, they noticed similarities. Pierce's last message referenced unexpected light against the ice wall at 18:2. Powell's data showed temperature shifts that preceded the unusual storm. The glowing patch inside Hollow Gate appeared at almost the same depth as the pressure fluctuation detected by Polish engineer Tomasz Rybak in 1991. These correlations did not prove a link, but suggested a recurring pattern. In 2003, meteorologist Fatima Rashid conducted a study comparing weather anomalies reported around Shadow Peak between 1,950 and 2,000. She identified 11 documented cases of sudden pressure drops lasting less than 10 seconds. 7 of those cases occurred within an hour of sunset. Rashid observed, "The timing does not match typical katabatic or convective behavior. The pattern seems internal, not atmospheric." Rashid also examined harmonic signals recorded by a seismograph placed near Broad Peak in 1982. Among the readings was a faint, low-frequency vibration lasting 9 seconds. Its amplitude was too small to indicate tectonic movement. Rashid noted that the vibration aligned in duration with Powell's pressure drop and with Minami's note about shifting air inside Hollow Gate. When she compared the three, she wrote, "They share a consistent interval, as if responding to the same trigger." Attempts to model the air movement around Shadow Peak using computational simulations produced no results matching the observations. Simulations showed natural turbulence dispersing within seconds. None produced the stable spiral or the clean pressure rebound recorded in 1976. A physicist reviewing the model commented, "The data implies a fixed boundary interacting with air, but no such boundary exists on the surface." Climbers who visited the ridge in later decades continued to report strange wind behavior. Some said gusts arrived without any preceding roar. Others described feeling vibrations through their boots before the air shifted. A Japanese climber in 2004 wrote, "Wind came upward from the ice, not downward from sky." Despite these reports, formal studies remain limited. The area is difficult to access, and funding for high-altitude atmospheric research is scarce. Most of what is known about the 1976 storm survives through logs, scattered datasheets, and handwritten notes. The event has no official classification. Yet, when the research teams mapped all recorded anomalies on a single chart, they noticed an overlap. The center points of the disturbances formed an arc. The arc curved directly above the shallowest depth indicated on the Soviet-era map. No further explanation has been offered. The climber who came back changed. In early June of 1998, a solo climber named Daniel Rourke arrived in Skardu with a simple objective. He planned to attempt an undocumented line that ran along the northern ribs of Shadow Peak. Rourke was known for quiet ascents and minimal gear. He kept no public journals and rarely joined large expeditions. Climbers remembered him as a man who stayed to the edges of campfires, listening more than speaking. His permit listed a 5-day window. He told porters he expected to return in 2. Rourke left base camp at 3:40 on June 12. The cook on duty, Zahid Malik, later said the morning air appeared stalled, as though the cold had settled lower than usual. Rourke carried a small pack with only essential items: an altimeter, 2 ice screws, a coil of rope, and a sample container used for geological studies. He gave no reason for the container, though he had a background in mineral analysis. Before leaving, he said one sentence recorded by a British climber nearby: "I want to see where the ridge begins to echo." For the first hours of the ascent, Rourke's progress followed a normal climber's pace. Tracks in the snow were clear and direct. By midday, he reached a point near an ice formation known to porters as the Cold Step, a section where temperatures remain lower than surrounding slopes. After this point, his tracks vanished. Searchers later noted no drifted snow or wind abrasion strong enough to erase them. The trail stopped, as if cut away. Rourke returned to base camp 20 hours after departure. His clothing showed no tears or ice scoring. His pack was zippered closed. Yet his behavior indicated something had gone wrong. Witnesses said he walked in a straight line without reacting to voices. Zahid Malik guided him to a chair and noticed his gloves were missing. They were not found along any part of his known route. When asked where he had been, Rourke gave no response. He stared downward and repeated a single phrase. It moved again. Climbers nearby tried to clarify what he meant. Rourke did not answer. He only resumed breathing in steady, slow intervals, as though focusing on each inhale. His altimeter showed a recorded high point of 6,030 meters. That altitude did not correspond to any part of the route he had planned. No map shows a shelf or path at that elevation along Shadow Peak's northern wall. Inside his pack, the sample container held fragments of ice. The pieces were thicker than typical glacier ice and showed sharp edges, as if broken from a solid sheet. When thawed, they separated into layers with visible striations. A geologist from a nearby South Korean team examined them and wrote, "Ice density inconsistent." Layer spacing suggests rapid freeze under atypical pressure. The ice also contained a faint metallic sheen, similar to the fragments found in 1987 near Camp. No known process on Shadow Peak produces such material naturally. In the hours after his return, Rourke appeared sensitive to sound. When metal struck stone near the cooking area, he flinched. When wind passed between tents, he covered his ears. A French climber, Lise Fournier, later recorded, "He behaved as if noise came from inside the mountain, not outside." By evening, he regained some awareness. He drank water and answered 3 questions. When asked what he saw, he said, "Blue light on the inside." When asked whether he reached the ridge, he responded, "The ridge turned." When asked why he returned without his gloves, he whispered, "It asked for them." Rourke never explained these statements again. The next day, he packed his equipment and left with a small group traveling back to Skardu. On the trail, he walked with steady footing, though still quiet. Porters noted he avoided looking toward Shadow Peak. At Skardu, he booked a flight and disappeared from climbing records. Attempts to contact him in later years produced no replies. His home climbing club in New Mexico confirmed he stopped renewing membership after 1999. The sample fragments retrieved from his pack were transported to a research group in Rawalpindi. Under microscope, the layers displayed microbubbles arranged in linear patterns. A physicist analyzing the sample said, "The bubble alignment looks influenced, not random freezing." When exposed to slight heat, the layers separated into thin sheets that curled at the edges, unlike normal melt behavior. Some sheets fractured with a soft crackling sound. One document in the Rawalpindi archive, dated September 1998, notes that the ice sample contained a trace compound resembling titanium oxide. The concentration was low, but unusual for natural ice formation at that altitude. Scientists offered no conclusion. Later that year, climber Helena Thurston visited base camp to examine the terrain linked to Rourke's ascent. She walked the same route up to the Cold Step. She found no branch path that could lead to 6,030 meters. No ice wall showed signs of recent breakage. No depression in snow hinted at a fall or slide. She wrote in her log, "The mountain shows no receipt of him." Word of Rourke's behavior circulated among porters. One claimed Rourke spoke briefly in the night before leaving, saying, "The sound doesn't reflect, it goes through." Another recalled that Rourke warned him not to sleep near the ice wall if he returned in the future. No official report was filed, as no disappearance occurred. Rourke's condition improved by the time he reached Skardu, but his statements remained part of the region's quiet stories, shared among guides who speak of wind that rises without direction and ice that holds pressure for reasons unknown. The ice sample remains in storage, sealed in a temperature-controlled case. It has not been reanalyzed since the late 1990 seconds. The file attached to it contains one handwritten note: blue light seen at depth, unknown origin. No new trails have been cut toward the area Rourke claimed to reach, the echo beneath the ridge. In February of 2006, a small research team from the University of Lahore placed 3 portable seismographs along the Baltoro glacier. Their work focused on assessing micro-movements in the region's ice sheets. The devices were positioned at measured intervals, one near Concordia, one beneath the western slope of Broad Peak, and one close to the lesser-known northern base of Shadow Peak. The team expected to capture routine glacier noise, creaking, cracking, and slow shifts common to high-altitude ice. Instead, the station nearest Shadow Peak recorded a recurring signal that did not resemble natural seismic patterns. The signal appeared first on February 14 at 3:12. It came as a low-frequency pulse, lasting 9 seconds. The amplitude was small, but its shape was remarkably clean. Natural ice shifts create irregular curves. This pulse rose and fell in a smooth arc. It repeated again at the exact same length, 27 minutes later. The team initially assumed equipment malfunction, yet the other 2 seismographs, located kilometers away, did not detect the signal. Only the device facing Shadow Peak did. Over 10 days, the same pulse returned 14 times, always 9 seconds long, always within the early hours before sunrise. On colder nights, the signal appeared slightly stronger. A graduate researcher, Imad Sadiq, studied the printouts and wrote, "The curve suggests a controlled origin. Natural resonance would distort under temperature shift." Sadiq compared the data to historical readings collected from a Broad Peak instrument in 1982. Among the archived records, he found a faint 9-second vibration logged on August 3 of that year. No explanation accompanied it. When matched side by side, the waveform bore resemblance to the 2006 pulse. The similarity raised questions that no one on the team could answer. In April, Sadiq contacted a French acoustics specialist, Dr. Émile Barraud, who had experience modelling subterranean resonance. Barraud analysed the recordings and sent a short statement: "The wave behaves as though bouncing between boundaries, but there is no evidence of cavities at the required scale." When asked whether the source could be glacial movement, Barraud replied simply, "Not with this regularity." A later review compared the pulse timing to temperature logs from the same days. The pulses aligned with moments when surface temperatures dipped rapidly sharp declines that lasted only minutes before rising again. Meteorologist Fatima Rashid, who had earlier studied anomalous storms around Shadow Peak, noted this correlation. Her comment in the margin read, "Pressure echoes?" In June, climbers stationed at a camp near the ridge reported hearing a sound they described as a distant drum under snow. One climber, Norwegian alpinist Jens Winter, said the vibration ran upward through his boots. He compared it to a cable humming beneath tension. Winter recorded in his log, "It did not come from above, it rose from the ice." Search teams referencing older cases soon recognized the 9-second interval. In the logs from 1976, Dr. Powell had documented a pressure drop lasting exactly 9 seconds before the sudden storm struck. In 1987, during the search for Pierce and the Knorr brothers, rescuers lowering a camera into Hollow Gate described a moment when the steel line trembled for a count close to 10. In Tetsuo Minami's notebook, the phrase "air moves for 9" appears beside sketches of the crevasse interior. These recurring intervals did not confirm a connection, yet the pattern was difficult to dismiss. Climbers reviewing the data remarked that Shadow Peak seemed to speak in measured lengths, never chaotic, always controlled. When these ideas circulated in the glacier camps, local porters referred to an old phrase, "The ridge answers in its own time." Expedition leader Serge Petrov, stationed in the area during the 2006 research period, attempted to physically locate the source of the vibrations. Petrov's team approached a region of fractured ice, leading toward a narrow depression that aligned with the Soviet-era map corridor. They placed a lightweight sensor in the depression and waited through the night. At 2:49, the sensor recorded a short tremor, followed by a faint upward shift in sound frequency. The shift lasted 9 seconds. Petrov wrote, "Not a tremor, a reply." Quo, The next morning, the team inspected the ice surface. They found a long, shallow indentation that had not been present the previous day. It measured approximately 10 meters and curved slightly toward the ridge. The indentation was smooth, without debris or fracture lines. Petrov described it as something pressed from below, then withdrew. Later, analysis revealed that each recorded pulse during the February period carried a minor harmonic pattern. The harmonics formed a repeating ratio consistent across all 14 pulses. No natural glacier event documented in the region had ever displayed this pattern. Barod suggested that the waveform resembled resonance produced when air passes through a constricted chamber, though no such chamber had been identified anywhere beneath Shadow Peak. The research team returned in September, hoping to capture more data. By then, the pulses had stopped. The seismograph remained silent for the entire month. Only at the end of the season, on September 29 at 4:05, did a single pulse appear. Like the others, it lasted 9 seconds. It came without wind, without snow movement, without any measurable surface activity. Sadiq called it a closing line. Attempts to locate any subsurface chamber using ground-penetrating radar produced scattered results. At depths between 40 and 50 meters, the radar returned irregular reflections, as though bouncing off uneven surfaces. Some reflections were sharp, others diffuse, but none offered a clear picture. Engineers claimed the reflections did not behave like rock or ice. A small footnote added to the final 2006 research report stated, all pulses intersect along a path that aligns with the unexplained corridor indicated on the Soviet map. The note carried no interpretation. It served only as a point of reference. To this day, the pulses recorded that winter stand as one of the most unusual seismic events documented in the region. Climbers still mention them when discussing the mountain's quiet patterns, air that shifts without storm, ice that echoes without movement, and a rhythm beneath the ridge that seems to return on its own schedule. No further pulses of similar clarity have been captured since. The night of the Twin Lights. In August of 2011, 2 experienced climbers, Swiss alpinist René Baumann and Nepali guide Temba Dorje, camped on a narrow ridge overlooking the northern face of Shadow Peak. They were scouting a secondary approach route for a documentary crew scheduled to arrive later in the season. Their location sat nearly 4 kilometers away, offering a clear line of sight toward the ridge that had carried so many unanswered stories. The night was calm, with low wind and a thin haze that drifted above the glacier. At 21:14, Baumann stepped outside the tent to secure a loose strap. He paused when he noticed a faint pulse of light below the ridgeline. At first he assumed it was the reflection of a headlamp from a distant team, but no expedition was known to be climbing that side of the mountain. The light lasted a second at most, disappearing as quickly as it appeared. He called for Dorje, who joined him moments later. They watched as a second flash emerged. This one rose from inside the glacier. Dorje described it as a glow pushed upward, not outward. The light appeared blue, with a rounded edge, as though shaped by the ice around it. 10 seconds later, a second light appeared beside the first. The 2 glows pulsed in alternating intervals, faint but distinct, like slow breathing beneath the surface. Baumann recorded the time between pulses, 9 seconds. The lights continued for nearly a minute before fading. Neither climber heard accompanying sound. Dorje later said, "The air did not change, no wind, no echo. They noted no reflection from moonlight or outside source. The flashes came from below the glacier, not above it." Baumann attempted to photograph the lights, but by the time the camera was prepared, the final pulse had disappeared. When they reviewed the images later, none captured the event. Yet both climbers provided matching descriptions when reporting the sighting to the Alpine office in Skardu. Their statements were filed separately, showing no discrepancies. The next morning, Baumann hiked to a nearby outcrop to check for surface disturbances. He found nothing unusual, no fractures, no depressions, no melt pockets. Snow, along the northern face, remained undisturbed. Dorje remarked, "It is like the ice did not remember." When the pair returned to base camp, they consulted the logbooks kept by previous expeditions. In one from 1994, a German climber had described seeing 2 faint lanterns beneath the ridge, though she believed it to be reflected sunlight on crystallized ice. Another entry from 1968 by a Polish team mentioned paired glimmers seen on a cloudless night. The notation was brief and offered no context. A 1979 Japanese log referenced twin shapes of light rising from within the glacier, though the phrasing was unclear. The alignment between the earlier accounts and the 2011 sighting intrigued researchers. It also reflected a recurring pattern. Each report mentioned dual lights, not single ones. All described a blue or white glow. Several referenced a sense of symmetry, as if the lights were coordinated. Meteorologist Fatima Rashid reviewed the recorded weather data from the night of the 2011 sighting. She found no anomalies. Temperature dropped slowly, wind remained constant, and atmospheric pressure held steady. Nothing in the observations explained the bursts. In September, Baumann and Dorje were interviewed by a team studying seismic activity in the region. When asked whether the lights appeared rhythmic, both affirmed they did. Baumann's recorded pulse intervals of 9 seconds matched the seismic pulses captured in 2006. Dorje added that the lights seemed linked by something beneath the ice, though he avoided speculation on what that might be. A month later, researchers placed a compact geophone within the area facing the northern ridge. For 2 nights, the instrument captured no unusual signals. On the 3rd night, a faint tremor appeared lasting 9 seconds. It coincided precisely with the time Baumann had recorded the lights during their observation. The geophone did not capture additional pulses. Local porters, hearing of the event, shared older stories. One spoke of a tale passed down by his grandfather, who claimed the mountain sometimes opens its eyes in pairs. Another mentioned a belief that certain ridges store the cold light that does not belong to sky. Such accounts, though not scientific, carried a consistency unusual for oral tradition, spread across different generations of guides. Attempts to locate any direct source of reflected light near Shadow Peak also failed. Ice cores taken during subsequent climbs showed trace metallic elements similar to the samples recovered in 1987 and from Rorke's Pack in 1998. These metallic traces remained unexplained. Geologists could not identify any local mineral process that would produce reflective properties capable of generating paired flashes. In the following climbing seasons, several climbers set up night watches at various vantage points across the glacier. None managed to observe a repeat of the twin flashes. 2 climbers in 2015 reported seeing a faint glow, but it lacked the distinct pairing described by Baumann and Dorje. The Alpine Office marked the 2011 event as unverified but credible, acknowledging the experience of both witnesses. Some researchers proposed that the flashes could result from rapid ice fracturing within paired cavities, yet no acoustic signatures accompanied the lights, and natural ice fracturing does not typically produce synchronized pulses or uniform timing. Others suggested localized aurora effects, but the Karakoram lies outside the usual geomagnetic influence for visible auroral activity. When the 2011 incident was compared with earlier records, archivists found an unusual detail. Each sighting of twin lights corresponded to a year when pressure anomalies were recorded near Shadow Peak. The 1968 Polish entry matched a year when a short-lived pressure dip was documented by a Soviet weather station. The 1994 German sighting paralleled a year when a seismic irregularity echoed beneath the ridge. And the 2011 sighting aligned with a period of minor frequency shifts captured by microsensors placed along the glacier. None of the researchers claimed these correlations provided answers. Instead, they raised further questions about the nature of the phenomena tied to Shadow Peak. Baumann later described the experience in a brief interview. The lights did not shine, they breathed. They rose through the ice as if the glacier was not solid. Dorje offered a simple remark when asked if he feared what he had seen. It was not a warning, it was a reminder. The night ended quietly. The mountain remained still. Yet the memory of the twin lights lingered in each account, joining the growing list of observations pointing towards something beneath Shadow Peak that moved in its own rhythm and surfaced only when conditions allowed. The ridge that should not shift. In the summer of 2014, the Pakistan Geological Survey partnered with a small Italian research group to update elevation models for the Baltoro region. Advances in satellite imaging and new ground sensors allowed for more precise measurements than earlier expeditions. Their work included brief surveys of lesser-known formations, including Shadow Peak. The mountain had not been formally mapped since the early 1992, and its ridge data remained incomplete. The team expected minor erosion, natural settling of snow layers, and shifting ice plates. Instead, they recorded a ridge deviation that did not match any known natural process. The survey began on July 4. The team placed reflectors along the northern ridge and calibrated them with a laser rangefinder. Weather remained stable. Measurements taken that afternoon produced a clean profile with no anomalies. The ridge showed the expected contour, steep toward the north, more gradual toward the west. Nothing indicated instability. On July 5 at 9:10, the team repeated the scan. The ridge outline displayed a slight but measurable shift. A section roughly 40 meters long appeared displaced inward by approximately 60 centimeters. The shift was too small to notice with the naked eye, but significant enough to register on the instruments. Lead surveyor Dr. Elena Marchesi checked the calibration 3 times. She suspected equipment error, but when a second device produced the same reading, she noted ridge displacement inconsistent with slide or drift. Natural erosion does not produce uniform inward movement across an isolated segment. Snow compaction can cause surface irregularities, but the ridge area had minimal snow coverage that season. No rockfall traces were found. Marchesi and her Pakistani counterpart, engineer Hassan Riaz, walked the affected stretch later that morning. They found no fractures, no fresh debris, and no collapse zones. The rock felt stable beneath their feet, cold but unyielding. Riaz wrote, "Structure unchanged. Instruments disagree with surface." On July 6, the team expanded the scan radius. A second shift appeared this time lower on the ridge. It measured 20 centimeters and followed a gentle curve that aligned with the path seen on the Soviet-era map's shaded corridor. Marchesi paused her work and filed an internal note, deviations forming pattern rather than random distribution. When the data were plotted on a single chart, the shifts formed an arc, similar to the one meteorologist Fatima Rashid had identified while studying the 1976 weather anomaly. The overlapping patterns suggested a moving boundary beneath the ridge, something large enough to affect structured measurements, but subtle enough to avoid detection at ground level. On July 7 at 22:40, the team recorded a faint vibration beneath Camp 1. It lasted only a moment, and none of the climbers reported feeling it, but one of the ground sensors captured a short-lived resonance lasting 9 seconds. The timestamp matched the pulse interval noted in 2006, 1982, and the recorded observations from multiple expeditions. Marchesi wrote, "Unexplained acoustic event beneath ridge. Duration consistent with historical anomalies." The next morning, Riaz attempted to map the ridge interior using a compact radar unit. The device returned scattered reflections at depths between 30 and 50 meters, similar to the inconsistent results obtained by earlier researchers. The reflections shifted slightly over 15 minutes, indicating movement beneath the ice or rock. Riaz repeated the scan at a different angle. The pattern remained, though displaced by several meters. He described the reflections as like fabric being pushed from below. Marchesi studied the earlier Soviet chart for comparison. The depth markers on that map, labeled 46 meters, 51 meters, and 56 meters, corresponded roughly to the radar reflections. She wrote a single sentence in her field notebook: "Something beneath ridge is not fixed." On July 9, the survey team noticed a second anomaly. A small depression formed along the western edge of the ridge. It measured only a few centimeters deep, but extended for nearly 10 meters. Snow around the depression remained undisturbed. No meltwater pooled nearby. Marchesi placed a hand on the surface and felt a faint warmth, unusual at that altitude and time of day. The warmth faded within seconds. Riaz, touching the same point afterward, felt nothing. Climbers stationed near Camp 2 reported hearing an unusual sound that night. It was not wind, not ice cracking, and not distant rockfall. A Spanish climber described it as a long, soft exhale through stone. Another said the sound came from somewhere inside the ridge. The noise lasted 9 seconds. No further sounds followed. On July 10, the ridge profile shifted again. This time, the displacement measured almost a full meter along a narrow section. Such change normally accompanies collapse or slippage, yet the surface remained intact. The rock showed no stress lines. The snow held firm. Marchesi recalculated the data 5 times and found the same result each time. By this point, the team faced a dilemma. If the ridge was unstable, they needed to report it as a hazard. If the instruments were faulty, they needed to halt the survey. But the instruments showed stable readings everywhere except Shadow Peak. To confirm their findings, Marchesi requested a satellite pass from a European monitoring program. The satellite recorded the region 2 days later. The image showed a slight distortion on the ridge, matching the displacement measured by the ground team. The distortion was subtle, but present. The team withdrew from the ridge area on July 13 after agreeing that continued work posed potential risk. Their final report described the shifts as mechanically inexplicable under known conditions. No mention of the earlier anomalies, light pulses, harmonic vibrations, or the Soviet map noted in climbing archives was included in the official document. Those details were shared only among researchers familiar with the mountain's unusual record. When the data were quietly compared with earlier ridge measurements from the 1987 search effort, archivists found that the ridge had shifted once before. The displacement measured informally at the time had occurred within a zone overlapping nearly half of the 2014 anomalies. The earlier shift had been dismissed as measurement inconsistency. Riaz, reviewing the overlay, wrote, "The ridge has moved before. Each time, the change is deliberate, not random." Climbers who passed through the region in later seasons mentioned a faint new curve along the ridge when photographed under certain light. Some said the mountain leans inward now, though others saw no difference. As of the last recorded survey, no collapse has occurred. The ridge remains intact. Yet its profile, once thought static, now carries small but undeniable evidence of controlled movement, each shift aligning with a pattern traced through decades of unusual events tied to Shadow Peak. Nothing further has been published on the ridge deviation. The camp that heard a voice. In the winter of 2017, a small glaciology research group from the University of Trondheim established a temporary camp along the northern corridor beneath Shadow Peak. Their goal was straightforward: record seasonal freeze patterns and document the behavior of thin ice layers under extreme temperature shifts. The team consisted of 4 members: Dr. Ingrid Solheim, field technician Lars Østby, geophysicist Anna Mikkelsen, and graduate researcher Pavel Ilyin. They chose February for the study, when the glacier remained at its most stable and foot traffic in the region was nearly non-existent. On the night of February 18, temperatures reached negative 27 degrees Celsius. Winds fell to almost zero, leaving the camp quiet except for the creak of cooling metal and the slow settling of snow. At 2:11, the first unusual sound rose through the ice. Ilyin, who was awake, reviewing data logs, noted the event in his notebook. He described it as a faint tone rising upward, not lateral. The sound lasted approximately 4 seconds and carried a clarity he could not attribute to structural movement. He woke Solheim, who stepped outside to listen. At first, the glacier lay silent. Then, at 2:21, a second sound emerged. This one lasted 9 seconds. Solheim later wrote, "It did not vibrate through air, it travelled through surface." She placed her glove against the ice and felt a soft rhythmic pressure, as though the sound was pushing upward from below. The other 2 team members joined them. Østby believed the noise came from a distant crack line shifting deep in the glacier, but Mikkelsen disagreed. She noted that natural fractures yielded irregular sounds, snaps, groans, uneven echoes. The sound they heard was steady, even, intentional. At 2:43, the sound returned, this time louder. A single rising tone, followed by a brief pause. Then a second tone, slightly lower. The pattern resembled 2 syllables, spoken slowly. Østby, startled, asked if the glacier could produce acoustic resonance capable of forming something so close to structured sound. Solheim replied, "Only if shaped chamber exists beneath us." No such chamber had been documented. The team deployed a portable contact microphone on the ice surface. The microphone captured faint vibrations, but failed to extract the full tone. The waveform that appeared on the device carried the same clean curve seen in earlier seismic pulses recorded in 2006 and in the unexplained 1982 reading. The length, 9 seconds. At 3:10, the sound came once more. This time, the tone shifted, rising sharply at the end, as if responding to something. Mikkelsen whispered, "It's answering." Ilyin agreed, comparing the tone to breath pressed through a narrow opening. None of the team moved. When the sound faded, the glacier fell quiet again. The next morning, the group examined the area around the camp. They found a circular depression near one of the sensor poles. The depression measured less than 2 centimeters deep, but was perfectly round. Snow inside it appeared slightly compacted, not melted. Østby suggested it formed from settling. Solheim doubted it, noting that such smooth curvature required uniform downward force, not random compaction. When they returned to the tent, they noticed frost crystals forming in thin vertical lines on the inner fabric. Frost typically spreads irregularly or gathers at seams. These crystals formed in straight, narrow bands, parallel to one another. Michelson touched them gently. They vibrated. She documented the pattern and wrote, as if exposed to standing wave. During the second night, the camp recorded no unusual acoustics, but the temperature logs showed a brief rise of 3 degrees inside the thin ice layers. Beneath the camp, a pattern identical to the unexplained temperature shifts noted during the 1976 weather anomaly and the readings that preceded the 1987 disappearance. The warming lasted 9 seconds. On the third night, at 1:58, the sound returned. This time, it was much quieter. The tone emerged from deeper beneath the glacier, muffled yet clear. Solheim instructed the team to remain still. The sound lasted 9 seconds, repeated once, then stopped completely. Afterward, the air around the camp felt unusually dense. The team reported mild pressure in their ears. Ilian, reviewing the data hours later, noticed that the final 2 tones came at precise intervals down to the 10th of a second. Nothing in natural glacial processes produces such accuracy. He wrote in the margin of his log, "If this is environment, it is controlled." At sunrise, the team intended to reposition their sensors closer to the ridge. As they prepared to leave, SB noticed faint markings on the ice surface, shaped like elongated arcs. The marks did not resemble animal tracks or crampon prints. They ran parallel to each other, bending slightly inward. He traced them with a gloved hand and felt the ice humming faintly, as if holding residual vibration. The markings matched earlier descriptions recorded by Petrov's group in 2006, when a long, shallow indentation appeared near the ridge after a seismic pulse. The curvature also aligned with a depression found in the 2014 Ridge Shift survey. Solheim circled the marks and remarked that all 3 sets of evidence, seismic, structural, and acoustic, pointed toward activity beneath the mountain rather than on its surface. The group ended their fieldwork early. Their report, submitted to the University of Trondheim and the Alpine Office, listed the event as low-frequency resonance of unknown origin. An appendix included the 9-second waveform, identical in structure to the pulses linked to earlier documented anomalies. Unofficially, the team referred to the event as the voice, not in a literal sense, but as a sound shaped with intention, timed, clear, and repeated. When later asked if she believed the glacier had produced a form of communication, Solheim responded, "I do not claim it spoke, I claim it answered." No further recordings of the phenomenon were captured that season, the glacier that did not behave as ice. In the late summer of 2019, a joint Pakistani-Norwegian research project deployed a thermal imaging drone system along the northern basin of Shadow Peak. The team's objective was to test a new sensor capable of reading subsurface temperature gradients through compact ice. The technology had shown promising results in Arctic studies, mapping crevasses and hidden melt streams with high accuracy. Shadow Peak was chosen as a stress case due to its dense, cold ice layers and history of unusual measurements. The first drone flight launched on August 3 at 6:40. Air remained clear. Winds barely reached 5 kilometers per hour. The drone moved across the basin in a grid pattern, capturing standard thermal data. Most of the glacier appeared as expected, deep blues and muted greens, indicating temperatures far below freezing. But as the drone passed near the zone aligned with the Soviet-era corridor marking, a narrow band of warm color appeared on the thermal feed, just a thin line, almost vertical, descending into the glacier. The line measured roughly 12 meters across and carried a gradient inconsistent with sunlight or surface warming. Glaciers warm horizontally, not in vertical seams. The sensor operator, Dr. Sigrid Holm, flagged the anomaly and ordered a second pass. The warm band appeared again. Its temperature registered at -7 degrees Celsius, almost 10 degrees higher than the surrounding ice. Holm noted softly, "That should not be there." A third pass revealed something more unexpected. The band did not remain stationary. It had shifted 7 meters westward in under 30 minutes. Ice does move, but not in directional, localized bands, and certainly not in discrete, measurable increments over such short intervals. Team geophysicist Dr. Nadeem Qureshi suggested a mechanical error. Holm disagreed. She checked the drone calibration and found no faults. Later that morning, the drone captured a second warm band, rising from a depth of approximately 50 meters, the same depth referenced by Seismic Oddities in 2006, and the glowing patch recorded in 1987. This band curved upward, resembling a bent arc. When Holm layered the thermal image over historical ridge shift data from 2014, the curvature matched nearly perfectly. By noon, the research team deployed a second drone, equipped with a deeper imaging algorithm. This drone flew lower, its sensors optimized for vertical ice penetration. At 1312, its feed displayed a soft pulsation within the warm band, alternating brightness every 9 seconds. Qureshi stared at the screen and whispered the interval count. Holm later wrote in her field report, temperature oscillations synchronized, consistent with prior acoustic and seismic pulses. When the oscillations ended, the band blurred slightly, as though losing cohesion. Minutes later, it faded into the surrounding ice. The glacier regained its normal thermal appearance. On August 4, the research group launched another flight. The warm bands returned, but in different positions, always within the narrow corridor aligned with earlier anomalies. At one point, 2 bands appeared side by side. Holm noted their spacing mirrored the paired lights witnessed by Baumann and Dorje in 2011. The symmetry was unmistakable. By the third day, the patterns became more complex. The drone feed showed overlapping arcs and thin, wavering lines that rose and fell like slow-moving threads. Their temperatures fluctuated rhythmically. Holm increased the drone's sampling speed. The fluctuations resolved into a repeating waveform, one that mirrored, in visual form, the 9-second seismic curve recorded in 2006. Qureshi remarked, "It is as if the glacier carries a pulse." When the team attempted to capture a thermal image beneath Hollow Gate, the drone's sensor experienced interference. The feed pixelated, brightened, then darkened abruptly. A warning flashed on the controller citing a thermal conflict, a rare error that usually indicates strong radiant variation. The drone returned automatically. Holm reviewed the corrupted segment frame by frame. In 6 consecutive frames, a shape appeared faintly in the ice, not an object, but a silhouette of shifted temperature, forming a long, rounded curve. It resembled the same indentation described by rescue teams in 1987, and again by researchers in 2006. On August 6, the team deployed ground-based thermal rods for confirmation. The rods, inserted at shallow depths, recorded small pulses, temperature rising for 9 seconds, then stabilizing. These pulses occurred even when surface temperatures remained constant. Qureshi repeated the measurements at multiple points. Everywhere along the mapped corridor, the rods detected the same 9-second signature. Outside the corridor, no pulse occurred. Holm concluded that the glacier beneath Shadow Peak did not behave as a static mass. Instead, it displayed zones of movement, thermal, rhythmic, and localized, suggesting an internal dynamic independent of external weather or solar patterns. That evening, the team hiked to a vantage point overlooking the basin. As they reviewed the findings, a faint sound traveled through the ice, below them a soft, low resonance, lasting around 9 seconds. It was not loud enough to echo, yet distinct enough for all 4 members to acknowledge. Qureshi looked towards the ridge and said, "It follows its own pattern." The team ended their fieldwork 2 days early. Their final report, submitted to both Norwegian and Pakistani research offices, described the glacier's behavior as non-glaciological thermal dynamics, a neutral phrasing meant to avoid speculation. The appendix included the thermal scans, each showing the drifting bands and oscillating arcs beneath the surface. Privately, Holm added one more line in her notes. Temperature responds to something below. None of the thermal patterns have been documented elsewhere in the Karakoram. The glacier continues to shift in ways not fully measured. The corridor beneath Shadow Peak remains unmapped, the descent into Hollow Gate. In the winter season of 2020, a joint high-altitude research team organized an attempt that earlier expeditions had avoided. Their goal was simple in wording, but difficult in execution. Lower multi-sensor equipment deep into Hollow Gate using modern stabilization systems. No one had attempted a structured descent since the late 1980 seconds, when early cameras failed beyond 40 meters. This new effort brought compact light meters, pressure coils, inertial sensors, and a reinforced thermal probe designed for abyssal ocean research. The team hoped the improved resilience would allow at least partial mapping of the crevasse interior. The descent began on January 14 at 7:20. The air was still, the sun remained low behind Shadow Peak's ridge. Lead engineer David Kruger tested the winch once more before lowering the primary sensor pod. The pod carried 6 active modules and a high luminosity lamp capable of cutting through blue ice opacity. The first 10 meters yielded nothing unusual. The ice walls glowed faintly around the lamp, showing smooth vertical texture, with no lateral cavities or trapped debris. At 17 meters, the pressure sensor registered a slight dip, unexpected but not alarming. At 28 meters, the first anomaly appeared. The light meter recorded a faint bluish glow ahead of the pod, too dim to see with the camera but strong enough to register on the photodiode. Kruger asked for a recalibration. The glow persisted. It pulsed every 9 seconds. The pod continued downward. At 33 meters, the winch cable vibrated slightly. Climbers on the surface felt the tremor through their gloves. It lasted 9 seconds, matching the light pulse interval. No wind reached the crevasse mouth. When the vibration ended, the pod rotated slightly to the right without external pull. The team steadied the line manually. At 41 meters, the camera gained partial visibility. The pod entered a widening chamber, its walls curving inward and outward like the interior of a large shell. The lamp illuminated layered ice with strange consistency, alternating clear and metallic sheen striations similar to the fragments found in 1987 and again in 1998 from Rourke's pack. Some layers reflected light at angles too sharp for natural formation. At 43 meters, the depth long associated with the glowing patch described in earlier missions, the pod captured a dim source of light rising through the ice, not shining, but diffusing outward in a slow expansion. The team increased lamp strength. The glow dimmed in response. Kruger wrote, "Illumination counters illumination." The thermal probe recorded a sudden rise of temperature, exactly 9 seconds long before returning to baseline. The ice wall near the glow warped slightly on the visual feed, as if a thin layer shifted beneath the surface. The distortion lasted less than a second. At 47 meters, the inertial sensor registered lateral movement of the surrounding ice, though the pod remained stationary. The readings resembled a wave traveling through a medium rather than structural instability. The signal repeated at precise intervals. The scientist monitoring the vibration coil whispered, "It feels patterned." At 50 meters, the pod encountered a long, smooth depression running vertically down the chamber wall. It matched the curvature recorded in 2006 and the thermal silhouette captured in 2019. The depression looked carved, not rough, not cracked, almost machined, but the surface was natural ice. When the pod's lamp passed over it, the depression gave a faint internal shimmer. Kruger paused the descent. The team captured additional footage. The shimmer did not behave like refracted light. It moved slightly, bending toward the lamp, then retracting. The shift occurred over 9 seconds. At 53 meters, the pod emitted a soft chime the automatic alert triggered when environmental parameters exceeded predicted ranges. All 6 modules began returning inconsistent values. Pressure spiked momentarily, despite stable depth. Temperature rose by 4 degrees in a narrow band before stabilizing. The light meter registered a sudden beam from below, though the camera saw only milky haze. The most unusual reading came from the microphone. Though designed for vibration capture, not audio clarity, it recorded a low, steady resonance. Not a roar, not a crack, not wind. A single tone, perfectly even, lasting 9 seconds. Kruger ordered the pod lifted 20 meters to ensure safety. The winch operator turned the crank, but the cable tightened first, as though something resisted. For 3 seconds, the winch strained with no upward movement. Then the cable slackened. The pod rose normally. When the pod returned to the surface, the team examined it in silence. No scratches, no impact damage, but the sensor housing carried a faint warmth that dissipated within moments. The thermal probe, designed to withstand deep ocean pressure, showed unusual internal condensation, something that should not form in the extreme cold of the crevasse. The most significant detail, however, lay inside the light meter housing. Fine granules of metallic material, silver and black, clung to the inner edge. When analyzed later, the granules matched the unusual sediment found in Pierce's 1987 samples and in the ice fragments collected by Rourke in 1998. The consistency across decades of unrelated samples was impossible to ignore. The team planned a second descent the following day, but at sunrise, they found the crevasse mouth altered. One side had shifted inward slightly, pressing the lip downward by several centimeters. No fracture lines indicated collapse. The ice appeared smooth, as if molded overnight. The indentation bore the same curvature recorded in 2006 and 2014. Kruger stood at the edge and said quietly, "It moved." The team halted further attempts. Their report classified Hollow Gate as environmentally active, a neutral term that avoided speculation, while acknowledging that the crevasse did not behave like a static structure. The data remains archived. The footage has not been released publicly. The pod, though cleaned, still carries faint traces of metallic sediment in microscopic channels. Nothing further was retrieved from Hollowgate. No one has attempted a deeper descent since the season of the vanishing tracks. The climbing season of 2022 brought unusually clear weather to the Baltoro Glacier. For almost 6 weeks, the skies above Shadow Peak held steady, offering rare visibility across the ice fields. Several expeditions, research teams, climbers, and documentary crews operated in overlapping sectors. It was during this period of consistent conditions that a series of strange observations emerged. Each involved the same quiet detail. Tracks that appeared normal at first, then ended abruptly on open, untouched ground. The first report came from a Spanish-Korean climbing pair descending from a reconnaissance route on July 3. Their footprints trailed neatly across a stretch of hardened snow. Then, without drift or distortion, the print stopped. For 3 meters beyond that point, the snow lay smooth. No melt pattern, no wind scoring, no covering. The climbers checked their altimeters and returned to the last visible steps. One of them, Jaewon Song, placed a glove at the final print. No indentation met the glove's weight. The surface was firm. He wrote, "It is as if the next step was taken into air." 2 days later, a British team skiing toward a satellite camp encountered a similar pattern. Their ski tracks carved crisp lines behind them. At one section near a shallow depression, the parallel tracks disappeared mid-line. The lead skier, Harriet Lawn, described the cutoff point as clean as shears. No collapse zone existed, no soft patch. The snow held its structure. Lawn's team circled back multiple times, believing the marks had been obscured by spindrift, but no wind blew that day. The air held still over the glacier. On July 7th, a Pakistani porter group travelling between supply caches reported something more puzzling. They found 2 sets of human tracks spaced apart, walking side by side. The tracks remained clear for perhaps 30 steps. Then both sets terminated at the same point. The snow beyond appeared untouched. Porter leader Shafiq Ali tapped the ground with his pole. He felt nothing unusual beneath the surface. He later said, "No dip, no crust. The steps end because the steps do not go on." Researchers began documenting the track incidents, hoping to identify a consistent environmental cause. But the cases varied in altitude, time of day, and snow condition. Some tracks ended on firm crust, others on powder. A Japanese team found tracks that ended on glare ice smooth, blue, and unbroken. In each instance, the termination point looked deliberate rather than eroded. On July 11, a thermal drone flight captured one of the more striking cases. The drone recorded footprints stamped into snow, still holding heat from a recent passing. The prints ran in a straight line for approximately 10 meters. Then, at the final print, the thermal image showed a faint, warm spot, just a single circular patch. No further prints followed. The surface beyond appeared uniformly cold. When the drone zoomed in, the warm patch faded over 9 seconds, then disappeared. The timing did not escape notice. Around this same period, climbers stationed near Camp 2 heard a brief vibration one night, lasting 9 seconds beneath their tents. Though faint, the vibration coincided with a reported set of vanishing tracks, discovered the next morning, only a short distance from their location. The tracks were fresh, likely made by a climber during a pre-dawn walk. They ended near a small indentation in the snow shaped like a long arc. Several expeditions began cross-referencing the events. When plotted on a map, the vanishing track sites formed a curve. The curve aligned precisely with the corridor previously captured in thermal scans in 2019 and with the arc documented by redshift measurements in 2014. Even more striking, the alignment passed directly through the zone where the Soviet-era map indicated subsurface structure. On July 17, one final case emerged. A Norwegian climber named Erik Borg set out alone to adjust a weather station sensor placed earlier in the season. Snow around him was undisturbed. When he returned to camp 2 hours later, he noticed his own outbound footprints missing for a large section of his route. They existed at the start, then vanished for 20 meters, then reappeared closer to the sensor station. Borg insisted he had walked continuously. He said, "I never left the surface, but the surface did not keep my steps." His teammates examined the area immediately. Wind remained absent. Temperature shifts were mild. The snow surface showed no crusting or settling that could erase tracks so precisely. When they tried stamping new prints alongside the path, the impressions held firm. Nothing suggested environmental instability. The reports continued until the season closed. No physical hazard crevasse, frost pocket, or melt layer explained the patterns. The termination points never matched known collapse behavior. Each case displayed abrupt cessation rather than gradual fade. One detail repeated across interviews. At several locations, the final prints appeared slightly deeper than the preceding ones, as if the person walked with added weight just before the step vanished. This effect matched a description from a 1987 search record. One rescuer noted that the last print belonging to Khalid Noor seemed pressed downward more than expected, though no one understood why at the time. In review sessions held at autumn, analysts proposed theories: sublimation, microcrusting, optical distortion. None held when matched against the field logs. The track endings were too precise, too consistent, too frequent, and the 9-second intervals found in seismic readings, temperature pulses, sound events, and now thermal track data hinted again at the same repeating pattern. Documents filed by the Alpine Office listed the 2,022 incidents under the heading Locational Footprint Discontinuities. The term avoided implication. It simply acknowledged the evidence. Unofficially, climbers and porters referred to the phenomenon by another name: the path that doesn't need steps. Several guides began advising younger climbers not to travel alone along the corridor near Shadow Peak, not for fear of danger, but because the mountain does not always return what touches it. Others warned that the glacier remembers weight differently now, a quiet way of saying some things no longer left traces in the way they once did. By the end of the season, at least 12 vanishing track reports had been catalogued. No explanation connected them to one another, yet all circled the same narrow band beneath the ridge. The band that had warmed in pulses, the band that shifted, the band that echoed, the band that moved. No new incidents have been officially reported since the return to Shadow Peak. In the late season of 2023, after decades of scattered anomalies, a combined team of researchers and climbers assembled in Skardu with a single objective: return to Shadow Peak with every tool, record, and dataset gathered since the first disappearance in 1987. The group consisted of geophysicists, glaciologists, mountaineers, and 2 veteran porters whose families had worked the Baltoro routes for generations. Their permit application described the mission in neutral terms: multidisciplinary environmental study. But privately, the team hoped to answer a question that had grown more persistent with time. Why did Shadow Peak behave unlike any other formation in the Karakoram? The group reached base camp on September 4. Weather held unusually stable, matching the calm conditions noted during prior significant events. Lead geophysicist Dr. Farzan Jafari began by installing seismic plates around the northern basin, placing several directly along the arc, where vanishing tracks had been documented in 2022. Glaciologist Dr. Ingrid Solheim, returning after the 2017 acoustic event, set contact microphones against the ice walls. A small satellite dish relayed all readings to a server in Islamabad for real-time comparison with historical logs. On September 6 at 9:20, the first anomaly appeared: a faint tremor, consistent, smooth, and lasting 9 seconds. The team paused. The vibration repeated at 10:47, then again at 12:14. Each time the waveform matched the curves recorded in 2006, 1982, and several undocumented climber logs. Dr. Jafari whispered, "It's the same rhythm." Later that afternoon, the thermal team deployed a drone along the corridor where warm bands had appeared in 2019. The feed showed normal glacial temperatures until the drone reached the center of the mapped arc. At that point, a thin vertical band rose from the ice, warmer than the surrounding mass. It drifted slowly west, then vanished. Moments later, another band appeared 10 meters away. The drone recorded its oscillations 9 seconds apart. Nothing at the surface indicated motion. The glacier looked still. On September 7, the climbers began the ascent toward Hollow Gate. They traced the same route taken by Pierce, Imran, and Khalid in 1987. Snow conditions were stable. The markers leading up the ridge remained intact from earlier expeditions. Yet near the upper slope, they found something unexpected: a long, polished groove carved into the ice, smooth as glass. Its curvature matched the depressions observed in 2006 and again in 2014. It had not been there the previous day. "Fresh," one climber said quietly. "Very fresh." At 13:40, the descent team prepared a new sensor pod for Hollow Gate. This version, carried an improved light array, extended range microphones, and automated depth stabilizers. Before lowering the pod, Solheim pressed her glove to the ice at the rim. She felt a faint pressure rising, then falling. 9 seconds. The pod entered Hollowgate at 14.2. For the first 15 meters, the camera returned clear images of layered ice. At 22 meters, the thermal sensor detected a warm pulse. At 37 meters, the pod began to rotate slowly, though the cable remained taut. At 43 meters, the depth marked in every significant record, the light meter registered a dim glow ahead of the lens. This time, the camera captured partial visibility. A blue luminance, diffused like light behind frosted glass, expanded and contracted at steady intervals. The pod continued downward. The ice walls widened, forming a chamber similar to what earlier missions had described, but never fully filmed. Metallic striations ran across the walls, pulsing faintly with the glow. Temperature rose by 4 degrees. Pressure dipped. The pod's internal stabilizers clicked twice, adjusting for an unseen force. The descent team held the line steady. At 51 meters, the microphone captured a tone, long, low, and unmistakably shaped. It lasted 9 seconds. Then, another tone followed, slightly lower in pitch, a structured pattern. Solheim spoke softly into the recorder, not random, not natural resonance. The chamber walls shifted slightly, just a tremor, like a ripple, moving beneath ice. The glow brightened for a moment, then dimmed. Several members at the surface reported feeling pressure in their ears. A thin vibration ran through the ground beneath their boots. At 56 meters, the pod detected movement, not collapse, not falling ice. A lateral displacement, measured as a smooth curve pressing inward. The camera view blurred for a second, as though something moved between the lens and the ice, though nothing physical touched the pod. Then, at the deepest reading, 58 meters, the chamber brightened suddenly. A full-field luminance surged through the ice. Sensors spiked. For 9 seconds, the instruments captured overlapping signals: heat, vibration, pressure, and harmonic tone. The waveform matched the signatures from 1976, 1987, 2006, 2011, 2014, 2017, 2019, and 2022, all identical in length and ratio. Then the lights ceased. The glacier fell silent. The pod steadied on the line. All readings returned to baseline. The chamber darkened. The glow receded, as though pulled backward into the ice. The team lifted the pod slowly. It rose without resistance. When it reached the surface, they examined it as they had the 2020 device. Again, no impact marks appeared. But inside the joint seams of the lower casing, they found metallic residue, fine, silver-black grains, identical to those found in 1987, 1998, and 2020. That night at camp, no one spoke much. Each researcher compared the new data to decades of earlier anomalies. Every pattern aligned: the ridge shifts, the pulses, the lights, the warmth, the vanishing tracks, the resonance, the metallic sediment, all confined to a narrow corridor beneath Shadow Peak. On September 9 at dawn, the glacier beneath the camp vibrated once long enough for everyone to feel. 9 seconds. A slow exhale rising through ice. The team packed their equipment. Their official report classified the Hollowgate interior as a dynamic glacial formation with unexplained subsurface interactions. But privately, each member wrote a final line in their personal logs. Solheim's read, "It is not empty down there." Jaffrey wrote, "It responds." The two porters, speaking quietly in Balti as the group prepared to leave, offered the oldest phrasing in the region, one passed down long before the anomalies were recorded. The mountain moves when it remembers. The glacier remained still as they departed. No new vibrations came, no glow returned. But the corridor beneath Shadow Peak, after decades of quiet signs, had shown itself again. And then, as always, it went silent. What happened beneath Shadow Peak remains unproven, yet the pattern is clear. Decades of recordings, testimonies, and measurements all point toward a consistent presence under the ice, one that moves with rhythm, reacts to light, and leaves signs that vanish as quickly as they appear. The glacier does not behave like a glacier. The ridge does not hold its shape. Hollowgate does not stay still. The mountain answers even when no one is asking. If you want to continue exploring these forgotten cases, unsolved patterns, and quiet anomalies from remote regions of the world, subscribe to the channel and join us for future investigations. Your support helps us bring more of these long-form deep dives to life. Like the video, share it with others who follow hidden histories, and let us know which unexplained places you want to see next. The mountain may rest, but the search continues.